Good morning to all. Today our topic is on evaporators. Evaporator is a part of the refrigeration system. It is located low pressure side of the refrigeration system. It is located in between the expansion valve and compressor. Refrigerant entering into the evaporator from the expansion valve with low pressure and low temperature compared to the evaporator. So with that low temperature, low pressure refrigerant entering into the evaporator, it absorbs the heat from the evaporator and changes its phase. If it is absorbs the latent heat, otherwise changes its temperature. If it is absorbs the sensible heat and goes to the suction pipe and to compressor. So this evaporator is called as cooling coil. Sometimes it is called as freezing coil or liquid coolers. This evaporator mainly it absorbs the heat from the refrigerated space and converts the phase of the refrigerant. So the evaporators are mainly, so this is the construction of the evaporator. So this is the entry of the refrigerant. Here this is thermostatic expansion valve. So the refrigerant enter here, absorb the heat from the area and changes its phase. So this is the exit of the evaporator. So suction line is a suction line, that is the inlet of the compressor. Based on this condition of the refrigerant, this filler tube, filler bulb use the indication to the thermostatic valve. The thermostatic valve opens, the refrigerant entering into the evaporator. So this is the evaporator construction. So now the types of evaporators. The evaporators are classified into according to the type of construction: bare tube coil evaporators, funnel tube evaporators, plate evaporators, saline tube evaporators, and saline coil evaporators, tube-in-tube evaporators. Next, according to the manner in which the liquid refrigerant is fed, so that is flood evaporators and dry expansion evaporators, according to the mode of heat transfer, natural convention, and forced conventions, according to the operation of conditions, operating conditions, frosting evaporators, non-frosting evaporators, and defrosting evaporators. These are the different classifications. So first I starts with flood type evaporators. See, this is the flood type evaporators. So this is the main construction of the flood type evaporators. So this chamber is called as a flash chamber. This chamber is called as a flash chamber. So this is the entry of the refrigerant with low pressure and low temperature. So this is the float valve. It controls the flow of the refrigerant. The refrigerant level is increases. The refrigerant level is maximum level. At that time, this valve closes the flow. The refrigerant level is low. At that time, this valve is opens the and entry of the refrigerant into the flash chamber. So this flash chamber separates the flashes, that is liquid refrigerant and vapor refrigerant. So the vapor refrigerant collected in the flash chamber. This flash chamber, this is the baffle. The baffle main function is separate the liquid particles in the refrigerant, that is from the flashes, vapor refrigerant, and separate in collected and that liquid refrigerant to fall down into the flash chamber. Only pure vapor, that is without liquid refrigerant, liquid particles, vapor refrigerant is goes to the suction to the compressor. So now this liquid refrigerant goes to the bottom, and the this evaporator lines, this in this evaporator lines it is circulates and absorb the heat from the refrigerated space, absorb the heat from the refrigerated space. This liquid refrigerant absorbs the heat from the refrigerated space and converted into the phase changes, that is liquid to vapor. So this vapor is collected in this flash chamber, flash chamber, flash chamber. So this is the, that's why it is called the flash chamber. So in this flash chamber separates the vapor and liquid refrigerant, vapor and liquid refrigerant. So in this vapor only the liquid particles are separated with the help of the baffles, baffles. Only pure vapor is without liquid particles goes to the suction to compressors. So this is the float valve. This is the float valve. So this is the flood type evaporator. Flood type evaporator. So this flood type evaporator, the heat transfer efficiency increases because the entire surface is in contact with the liquid refrigerant at all load conditions. So this flood type evaporator have many industrial applications, particularly in chemical and food processing industries. Next one is finite tube evaporators. These finite tube evaporators are used in air condition applications. Generally, the fins are provided around the coils. See this figure. So this is a coil. In this coil, the refrigerant is pass. The refrigerant entering into this coil. In this coil, the refrigerant is circulates. So this the plates are mounted and fixed to these plates. The plates are these finite plates are fixed to this refrigerated tube. The refrigerant is passed through this tube. These finite plates are mounted on this refrigerated tube. So the refrigerant, it absorbs the heat from this finite tube. This finite tube absorbs the heat from the refrigerated space. So with the help of this finite fins, increase the area of cross section. The more air is contact with the finite tube, the finite tube absorbs the heat from the air, that air is supply gives to the refrigerant. The refrigerant absorbs the more heat from the finite plates and absorbs the heat from that finite plates and converted into the phase change phase changes. So that is the finite tube evaporators. These finite tube evaporators, so usually 4 to 6 fins are provided for each centimeters length, depending upon the operating temperature of the coil. The low temperature applications wide spacing is given between the fins to prevent the ice clogging. So this is the finite tube evaporators. So next one is shell and tube evaporators. Shell and tube evaporators, again it is fitted with a number of parallel tubes. It is similar to the construction of shell and tube condensers. These are also called as the chillers. These evaporators are called as two types. Again, the flooded type shell and tube condenser evaporators and the dry expansion shell and tube evaporators. See this figure. So, so this is the shell. In this shell, the tube is provided. In this tube, the chilled liquid is circulates. Chilled liquid is circulates. So this is the float valve with from the refrigerant enter from this inlet. Refrigerant enter from this inlet, and the level with a, due to this level indicate float valve. This with this level float valve, if the refrigerant level is maximum, the opening is closes. Opening closes. If refrigerant level is low, the opening opens. The refrigerant entering into the shell, opening into shell tube. So this fluid to be chilled is entering into this way, absorbs it rejects the heat to the refrigerant. Here the refrigerant is low temperature compared to the chilled liquid. The refrigerant absorbs the heat from the chilled liquid and changes its phase. This vapor refrigerant is collected in the top. So this area is provided for the vapor refrigerant. So this vapor refrigerant is collected at top portion of the shell, and that is goes to the suction to the compressor. Suction to the compressor. So the chilled refrigerant is enter from this top and goes to the bottom with this is with the high temperature entering into the some high temperature and absorb reject the heat to the refrigerant. So this is the exit of the chilled liquid with low temperature. Due to the density, it moves downward and goes to the refrigerated space, that is air conditioning space. So this is for the flooded type shell and tube evaporators. So this is the dry expansion type. See here, the liquid refrigerant enters from this area. This is the chamber. So this is the opening for the vapor. This is the opening for space for the vapor to be collected. Vapor refrigerant is to be collected. This the liquid refrigerant from this area and circulates through these tubes. Circulates through these tubes. The fluid to be chilled enter from this area, and the fluid to be chilled is circulates outer surface of the tubes and reject the heat to that uh, refrigerant. The liquid refrigerant absorbs the heat from that chilled liquid and rises its temperature and convert it into phase change. The phase change is refrigerant vapor is collected at this area and goes to the suction line, that is to compressor. That is to compressor. So next to shell and coil evaporators. Shell and in this shell and coil evaporators, so this is the shell and coil evaporator. This is the shell. In this shell, the coil is placed here. The coil is placed here. So in this shell, the refrigerant enters. The liquid enters into this coil, and and this is the exit. So the water water. This is the water in. Water in. This is the water in. So the liquid with low temperature, enters into the coil and absorbs the heat from the here the water from the water, the refrigerant, it changes its phase, that is from liquid refrigerant to the vapor refrigerant. The vapor refrigerant from this suction and goes to the compressors. The liquid refrigerant are next. Chilled water enter from this area and converted into and reject the heat to this coil. Reject heat this to coil. This low temperature chilled liquid collected at bottom and goes to the refrigerated space. So this is the shell and coil. This is the simple shell. The coil is located like here. The refrigerant is circulated in this coil and absorb the heat from the chilled water, and the refrigerant changes its phase. The wave changes its phase. The liquid to vapor. The vapor refrigerant from this line goes to the compressor. So this is the water liquid chilled liquid inlet, chilled liquid outlet. So this is the shell and coil evaporator. Thank you.